Hello and welcome to this lecture. In this video we are going to look at a very important topic known as recursion. We are also going to write a program based on this topic. Then we are going to look at preprocessor directives, which is quite interesting. Okay, let us start off with recursion. Now recursion occurs when a function calls itself. Let's say you have a function named function, and inside that functions you have several statements, and from that function you call the same function. From function you call function. Okay, and you have several other statements. Now what happens is when the control executes this function, it goes on executing the statements and it encounters a function call, and this function call is from the same function. The function is calling itself. So what happens is that the control jumps from here to here. Again it executes the same function. Now these are not executed. Now what is this is nothing but a function calling itself, and this is nothing but recursion. Now you can easily determine from this is that it is nothing but forming a loop, and this is an infinite loop. The control comes here, goes again to the function, comes here, again to the function, so it forms infinite loop. Now to understand more about recursion, let us consider a factorial program. What we'll do is try to calculate the factorial of a number. You know how to define a factorial, right? Let's say we have to store the factorial in the variable f, right? And let's say we have to calculate the factorial of 10. Now how to calculate the factorial of 10? Everyone knows 10 into 9 into 8 into 7 into 6 into 5 and so on until 1, right? Now let's see how do we go about calculating a factorial. So 10 factorial is nothing but 10 into 9 factorial, right? 10 into 9 factorial. 9 factorial goes on with 9 into 8 factorial, right? Similarly 8 factorial goes on with 8 into 7 factorial, and 7 factorial goes on with 7 into 6 factorial, and 6 again and again and again, right? The same procedure is followed. The cascading feature follows hereafter. And if you look carefully, this 9 is nothing but 10 minus 1, right? This 8 is nothing but 9 minus 1. This 9 minus 1. 7 is nothing but 8 minus 1, right? 6 is 7 minus 1. So what I'm trying to tell you is, if we consider this number 10, of which we have to calculate the factorial, if we consider this as n, this becomes n minus 1's factorial, right? So how can we generalize a function for calculating factorial? Is we have to store in f the factorial. So f is equals to, we have n into, the next comes is n minus 1 factorial. So factorial of n minus 1. So this is nothing but quite a formula to calculate the factorial of any number. Now let us write a function named factorial. Now this function named factorial is going to return an integer, so int, write it above, so int factorial is the name of a function, and it will accept n, right? We have to calculate the factorial of n, so it will accept n. Okay, now what we have inside is the body of a function. Let's write the body of a function. We have this formula ready. F is equal to n into factorial of n minus 1. So first write the return statement, right? It will return n. It will return factorial f. Return f. Right. And before it, we are calculating the factorial. So f is equal to, let me write it in another color. So f is equal to n into factorial of n minus 1. Now this is a recursive call. The control will go again to the factorial function. It will call again the factorial function. Now it forms an infinite loop, right? But we have to stop an infinite loop. Otherwise it will go on running and running, and it will never stop. So to stop an infinite loop, we have to write a condition. Based on a condition, we will have to stop. Now what would be the condition of stopping calculation of a factorial? If you look at this carefully, 6 factorial goes on with 6 into 5 factorial, right? This goes on with till 1 factorial comes, and 1 factorial is 1 into 0 factorial, right? And this 0 factorial is nothing but 1. So we stop at 0 factorial, which is 1. So we will have to use the condition if n is equal to 0. If n is equal to 0, we are going to return the factorial of 0, which is nothing but return 1. Right, 1 will be returned. Else, if it is not 0, then we calculate the factorial based on this method. So ultimately our loop is going to stop here, and it will come out of this infinite loop from this point, return 1. Let us write this program in a compiler. I've written this already for you. We have the factorial function which accepts an integer and returns an integer, returns the factorial of a number and accepts the number whose factorial is to be calculated. And rest is simple. What we have written already here, we have written the same here. We have just added a variable int f. We have declared it, and f is equal to n into factorial of n minus 1. If n is equal to 0, we are going to return 1. Now let us write the main function so that our program is capable of running. This time we are not going to take any input from the user, so let's declare a variable fact in which we are going to store the factorial of a number. Now fact is equal to, let's say we have to calculate the factorial of a number 3, right, for simplicity purposes, and we print factorial, right? Percentage is the factorial. In place of percentage, we are going to print the factorial variable's value, fact. Now let us run this program and see if it works or not. And yep, it is running perfectly. Factorial of 3 is 6. 3 into 2 into 1 is 6. Okay, now let us see how this concept of recursion works. Let's say we get the n as 2. For the sake of simplicity, let's consider n as 2. So what will happen is, it will check if n is equal to 0. 2 is not equal to 0, so it will go in the else part, f is equal to n into factorial of n minus 1. So this will be 2 into factorial of 2 minus 1, and this function will go to, it will call factorial, right? It will call itself. So instead of putting this arrow in the same function, I've created a copy of this function, so it will go here. And factorial this time will have 2 minus 1 is n as 1, right? Again it will check, is n is equal to 0, 1 is not equal to 0. Again it will go in the else part. Now n is 1 into factorial of 1 minus 1. Now this call will go here, right? 1 minus 1, this time n will have 0, and this condition is true, and 1 will be returned. Now where will this return? Will this return to the main function, or will this return to the calling function? So the calling function here is this factorial, so this will return to this function, right? Let's say this has returned to this. So what it has returned is 1. So 1 into 1, this factorial's value is 1. 1 into 1, f becomes 1, and this return will return to this function. Now what will this return? F's value is 1, so this becomes, the factorial of 2 minus 1 becomes 1. So 2 into 1 is the factorial which gets stored in f. This f is 1. Now where this will return is to main. Now remember that whenever a function call is made, the control returns to the calling function. Not necessary if the recursive call starts from main and then the recursion is within the function. So the control will return first within the function, and it will go on returning, and the last return will be to main if it is called from main for the first time. Now let us visualize what has happened here. What we had is to calculate the factorial of 2. Now factorial of 2 was nothing but 2 into factorial of 2 minus 1, which is 1, right? And this factorial was nothing but 1 into factorial of 0, right? We had this thing. Now let us solve this. Factorial of 0 was nothing but 1. This was 1. So we got the output as 1 into 1 as 1. Now this gets returned here. Now factorial of 1 we got here as 1, right? 2 into 1 is nothing but 2. Factorial of 2 is nothing but 2. So this way recursion work if we take the example of calculating the factorial of a number. Similarly, it works with other examples too. I hope you have understood the concept of recursion very clearly, because this is very important. If you have not understood, please replay this video again. Let us now jump to another important topic, preprocessor directives. Now preprocessor directive, preprocessor as the name suggests is processing beforehand, before processing, that is preprocessor, and directive is nothing but a command. Now we have been using preprocessor directive since we wrote our first program. We have been using this directive, #include. Now one thing to remember is that preprocessor directive always start with hash. Now include does nothing but it pastes the contents of header file wherever the preprocessor finds #include. Now preprocessor directives are used to pre-process our program, to expand our source code. Right? There are three types of preprocessor directives. One is macro expansion. Second is file inclusion. And the third one is nothing but conditional compilation. Conditional compilation. So the preprocessor expands wherever it finds the preprocessor directive. It expands this directive into some form of code. Right? So to understand the preprocessor or the preprocessor directives, one must need to understand the compilation process. Compilation process. So first of all, we write the source code or the program. Right, the program. This program, the very first operation or very first software our program goes through is the preprocessor. Please notice that I am drawing system programs, or the programs which process our software, our source code, are drawn in blocks. Right? Now the preprocessor outputs something called as the expanded source code. It expands our source code, the preprocessor. Now this expanded source code goes input to the compiler. Now compiler, we know, is a software that converts high-level language program to low-level language program. Now this compiler outputs what we call as object code. Object code is nothing but binary machine language code. Now this object code goes into a software called as linker. Now this linker outputs the executable file. Executable file which can be executed on a computer, which can be run on a computer. Now preprocessor, we know, expands our source code. It processes our source code before it goes into the compiler. Compiler gives us the object code. What linker does is it actually links to functions. Links to functions. Now what is called linking to function is actually what happens is you have different functions. You have standard library functions, you have your own user defined functions. Now what happens is your main function gets its own object code. It gets its object code. Your other functions gets their object code, and the standard library functions get their object code. Now the compiler, or when the program is run, it doesn't know where the functions object code is located in memory, or where the standard library functions are located in memory. Now linker actually links these functions together. So it gives the addresses of these functions in memory. While compilation, these addresses are relative, but when you run your program, they become actual addresses. So with this, let us start off with the first preprocessor directive, known as macro expansion. Now let me give you an example of macro expansion. Hash define. Hash define is the directive for any macro. Hash define, then you have the macro name and you have the macro code or some value. Now this, what we have written, is called a macro. hash define pi 3.1415. Now it is quite intuitive, right? It says that define pi this value 3.14. I'm sorry. Now what the preprocessor does when it scans your source code before it goes to the compiler, the preprocessor scans your source code. Now it replaces this pi with this value. Wherever it finds this string or these characters pi, it replaces these characters with this value. So if you have area is equals to pi into r, pi r square, right? So this pi will be replaced by 3.14, by this value 3.1415, right? It is actually nothing but giving some meaningful name to some code or to some constant value, right? The syntax is as follows: hash define, you have identifier, how to identify your code or your values, and you have code. Now by code I mean you can have any code. This time we had values, you can have code. Let us take an example. If I say hash define, let's say we have to define a macro called as new line, and new line will be replaced by this code. So this new line, wherever the compiler finds, wherever the preprocessor actually finds new line, it replaces new line with printf. So if you have a function main and you have to print something, printf hello, and then you say new line, and you say another printf, right? You can have anything here. Now what the output will be, the expanded source code will be printf hello, and this will be replaced by printf \n. So it actually replaces your identifier with your code, right? So we have defined a macro. There is also something called as undefining a macro. If you have defined hash defined pi as 3.1415, you can undefine it like this: hash undef pi. So value of pi will be undefined. Now it will not hold the value or the code 3.1415. One more point is to be noted is that macros can have arguments. There are also macros which accept arguments like we have in functions. So let me give you an example. Hash define square, and let's say it accepts the argument x, and this square x, this call to the macro, will be replaced by x into x. So this way a macro can accept argument. So if you have a is equals to square 5, so it will be replaced by a is equals to 5 into 5. Now this 5 goes here and it is replaced by like this: x into x, 5 into 5. You can also put a value into a variable and do like this: b is equals to square, and to this you can pass a variable. Ultimately the value gets passed. Let us take this example. Now you know what will happen. Some points to be noted are that this is not a space. please do not put space between the argument or in between the argument and the identifier. This is the macro identifier. There should not be any space in that, and one must include this within parenthesis, right? Okay, so the question is, should we use macros or should we use functions? Now macros is actually replaced with the code associated with that macro, and function is that the control jumps to that function. Now the judgment lies to you. If you use macros, your code will be quite lengthy, will be quite long. The expanded source code will be very much expanded if you use macros. But if you use functions, the code is much smaller. But macros do have an advantage, right? Macros run faster than functions. So if you have some smaller functionality to be implemented, you can implement it using macros. Functions are used if you want some robust functionality, right? So it's up to you if you use macros or functions. Functions are more flexible than macros. You can have so much functionality to be embedded into functions rather than macros. So for small petty tasks you use macros, for complex tasks use functions. So let us jump to our second type of preprocessor directives, file inclusion. Let me write the syntax of this file inclusion directive. We have used file inclusion directive throughout this series. So this is the syntax of file inclusion directive. We have used #include stdio.h. You can also include other files. So if you use what actually the file inclusion does, #include directive does, is it copies the contents of the file which you include into the place where this directive is written. So in place of #include file name, you have the contents of this file, right? So there are two ways of including a file. Now if you include a file like this, #include file name within angle brackets, so it searches the include directory. Include directory for this file. Now include directory is a special folder in the compiler where all the standard header files are stored. Now if you want to include a user defined or a custom header file or a custom file, you can use like this, #include file name within double quotes. Now what it does is it searches the local directory and the include directory. So local directory is where your source file is located. So if it's in the directory of the source file, you have to use this #include file name within double quotes. If you have your file to be included in the include directory, use this. But remember this also, if you use double quotes, it also searches in the include directory too. So let us talk about the third type of preprocessor directive, conditional compilation. Now what conditional compilation offers is it controls the compilation of the program. Controls compilation of program. You can specify which parts of the program to be compiled and which parts not to be compiled. Of course based on some conditions, right? So let me write the conditional compilation directive here. There are actually three types of conditional compilation directives. So the first one is Let me write the whole thing here. Suppose you have to compile your program based on a condition whether Intel is defined or not. So actually you have two types of codes, one for the Intel computer, another for the power computer. So if you want to compile your program for Intel computer, suppose, then what you do is you just define Intel. Now when the preprocessor sees that Intel is defined, so our condition is if defined, if def Intel. So this is true that Intel is defined, so this code will be executed and this will not be executed. By execution I mean this will be compiled. This code will not be compiled. So what we have at the end is the expanded source code for the Intel PC, not for the power PC. If you don't define Intel, if you have not defined Intel, this means that the code for power PC will be expanded. This will be deleted in the expanded source code. The counterpart or the opposite part of this if def is if ndef, if not defined. So hash if not defined, if ndef Intel. Let's say we are writing the same code, the contrapositive code for power hash else. That means if Intel is defined, so code for Intel, and we ndef. Now if ndef hash ndef, these hashes specify that these are preprocessor directives, right? So n means not. If not defined Intel, so if Intel is not defined, the code for power PC will be expanded. So these directives are based on if something is defined, or something is not defined. So we have to use the hash include, hash define directive also. There is another conditional compilation directive which does not depends upon something is defined or not. It is like this, hash if. It is just based on any condition, right? So hash if we have, let's say we have three types of codes: a code for a mouse, a code for joystick, and code for other devices. So we can have like this: if device is equals to mouse. So if device is equal to mouse, we can have the code for mouse here. Hash here we have elif, ELIF. So attention to be paid here. We had else here. We did not have any else if or such type there. We have in this, when we just use the hash if operator, we can also have elif, actually else if, right? So we write ELIF. Elif device is joystick, we have code for joystick. Now else, hash else, code for other devices, and then we have to ndef. Here we do not use the braces, we have to end every single if. So if you have the device as mouse, the code for mouse will be present in the expanded source code. These will not be present. Other codes will not be present. Same is the case if the device is joystick. The code for joystick will be expanded, others will not be there. So this is how you compile or you expand your code conditionally. So we had three types of preprocessor directives: macro, file inclusion, and conditional compilation.